Welcome to In the Open with Luke and Joe. I'm your host, Luke Shantz, and here's my co-host, Joe Seppi, and a big welcome to our special guest, Parul Singh. Before we get to our show, don't forget to like and subscribe. In this episode of In the Open with Luke and Joe, we bring you a conversation with Parul Singh, a senior software engineer on Red Hat's emerging technology team. We will be discussing the open source projects volsync, microshift, and the CRIS project, as well as her work with OpenShift's quantum operators. Before we welcome our guest, let's say hello to our co-host, Joe Seppi.
Hey, Luke. How are you, my friend? How's the weather over there?
I'm doing well, Joe. The weather is it's getting cool. I feel like autumn. I can feel it in the air. But although it's been very, we've had a lot of rain in the Northeast. You may have seen, flooding, serious flooding, some serious problems affected a lot of people. New York, Pennsylvania, New Jersey.
Yeah, the flooding was incredible. I mean, I think that we're both fortunate that we didn't experience it to that level. Certainly downpours. It was gushing over here, but no extreme flooding like I was seeing the videos in the city and stuff. It's really, really wild. But yeah, beautiful the day after, and today it is gorgeous out. It's kind of fall weather. I've got a lot of light jackets that I'm eager to pull out of the closet. So that's nice. That's real nice.
I'm looking for. I mean, we've mentioned that several times on the show, and I feel like we've been teasing the audience. I think we need to do Fashion Week where we see some of your fall jackets.
Oh, I got this one. I can't wait to show you. And I got a funny story about how I left it in San Francisco at a conference. And one of my colleagues, when I worked at the New York Times, actually went around to all the places we went, and he found it for me and brought it back. We'll save that for another episode.
True friendship.
So true.
Without further ado, let's welcome our guest, Parul.
Hi.
Hello.
How are you?
I'm going well. How are you guys?
Good. You're not far from us too, right? You're over in Boston. How's the weather up there?
Oh, don't ask. It's been raining fast few days, but today I feel like it's a little sunny. So my plants will like the weather today.
Yeah, and I'm hoping for good weather this weekend as well. That'd be nice.
Yeah.
So why don't we start with Parul, if you don't mind introducing yourself, we'll go from there.
Okay, so as you know, I am Parul Singh, and I work as a senior software engineer in the office of CTO, and I work for the Emerging Technology Group. What our group does is we try to think a year or half in advance and see what are the emerging tech and how they can be identified and aligned with the Red Hat technology. So my job is to go and find and research the emerging technology trend and then make cloud native prototypes and tie that back to find opportunities that can be aligned with Red Hat strategy.
Excellent. And I find emerging tech really interesting and kind of a really fun place to be doing that sort of work, development work and research. How long have you been there, and what are you excited about, and what are you kind of working on these days?
I am relatively new to this group, so I joined a year and a half, and I've been working on Red Hat for like almost just 2 years. So a year and a half, I was brought into emerging technology team, and I've been working on multiple projects. But the reason that I was brought in this team was to develop the IBM and OpenShift quantum operators. And for that, we have been using OpenShift to interact with IBM quantum backend devices. And the idea is to how you can bring quantum on cloud and democratize the access to quantum computers using open source API.
That's fascinating. I would love to dig in there if we can. I don't know if that's how our notes are lined up, but I'm curious. Like, so when we talk about quantum, Luke and I have gone and seen the quantum computers at the IBM facilities, and they're amazing. And there are these huge, rooms that need to be stabilized, like physically, and everything needs to be kept at a certain temperature. So how does this work in terms of the quantum work that you're doing with with OpenShift, like that's a big, crazy, super special computer, but you're able to do it with OpenShift. Like, how does that work?
So the idea behind is not all tasks or not all jobs are best for quantum computers, and there are also limitation of classical computer. So our vision was, how can we get the best of the both world, and how can you offload specific tasks that quantum computers are best at solving to quantum computer, while have the rest of the workflows on the classical computer. So that's why we developed these operators that can offload your quantum section of the job to the quantum computers while have the rest of the workflows running on OpenShift. And I've been working with the IBM quantum team, Ismail, and rest of the people were from Spain. So we've been developed these bunch of operators, and one of the operator is specifically just to help you get started on developing the circuits. And so imagine, like, if you are a quantum physicist or you are a quantum circuit writer, you are not a conventional software developer, and getting started installing the development environment, installing the libraries, understanding what are the dependencies, this is not what you're required to do, and it could be very overwhelming. So we developed this operator that can, just with a click of button, you can have the entire development environment set, and you can just start developing the circuits, because that's what your job is.
Yeah, this is fascinating to me, because again, I think about quantum as like this crazy wild computer, and I feel like it has felt so futuristic for a while. But if you're not paying attention, it's slowly like becoming sort of normalized. And I think about that in the sense of, OpenShift, but also, I know Qiskit, if that's how you say it, Qiskit. Yeah.
Everybody has their own pronunciation, but the creators of Qiskit call it Qiskit, so I call it Qiskit.
Yeah. And that's an open source framework, right, for working with quantum machines. And so my point, I guess, is that, like, the computer's wild and feels futuristic, but all of the things around it are starting to become, the things that we're used to doing, Kubernetes and OpenShift and open source frameworks to access it, and it just feels like it's becoming more normal. You know what I mean?
Yeah, it is an ever evolving technology. Believe me, the work or the APIs that I was working for a year they need to be changed right now. So it's like a very fast moving sector, and we are just trying to scramble and keep ourselves up to date. It's obviously it's not it is a time where people have started thinking quantum, and they're thinking how they can apply quantum to do optimization. It's initially people started with thinking that, if I apply quantum computers, I am just gonna change the computational speed exponentially. But as of now, if you see how the market is evolving, even getting a 5% optimization is like a huge deal. Imagine if you are fleet management service and you can optimize your route and your network even by 20% or 10%, it's a huge deal. So
I dropped a link down below if anyone's interested in seeing the quantum development roadmap from IBM. And as we're mentioning, we're in this very interesting time. I liken it to like the 1960s at NASA, where like all of this stuff is happening and going from like science experiments to like real deal, real world stuff, like as we speak. So if you want to check out that development roadmap, that's a great place to look at. And as you mentioned, it's very interesting. I'm a quantum ambassador, so I'm in this position where I don't really speak publicly like on a podcast about it, but I'll talk to companies about it and introduce them to what's going on. And it is, as you mentioned, right, like the optimization, and especially companies at scale, there's going to be these little things where, for instance, I went to a financial conference right before the pandemic hit. And while they may not be ready to use it today, all of these banks, all of these financial organizations are working on it now because they need to figure out the algorithms, they need to figure out the workflows, they need to get ready to be able to, for when it is real, you got to be competitive. So very exciting space. Please, I put this in the chat, and I will put it in the show notes. And one other note for everyone who's listening, if you have any questions for Parul, please drop them in the chat on whatever platform you're listening, and we'll get to them towards the end of the show.
Yeah, and I know I don't think we plan to dig into this too much, but I'm curious if you could share, because I think quantum is really interesting and exciting. Can you share like different technologies or fields that people might be thinking about quantum already and trying to work on that? I know, Luke had mentioned finance, and you had kind of mentioned, logistics, I guess you'd call it. Like, what sort of things are people thinking about in the quantum space?
There are many, of course, but it is being applied at also things like chemistry. Like whenever I'm giving a quantum talk, this is my favorite example, is as of now, you cannot represent a single atom of caffeine with the classical computers that you have. Even like the best classical supercomputer that you have cannot represent a molecule of caffeine.
Wild.
And if you want to go ahead and build that, it would consume almost 1/10 of the atoms on the Earth. But you can do you can do that with just I don't remember the exact qubits, but like it is manageable using a quantum computer. If you have a quantum computer that's scale of 64 qubits, you can represent a molecule of caffeine. So it's so interesting. And the example why I give this is because the application of quantum computer in chemistry, you try to find out what is the best molecular structure of medicines or fertilizers, and you don't even have to actually make them and test them. You can just build an algorithm that come up with different molecular configuration, and you can decide and you can learn from those molecular configuration which is the best or the best suited for the job it seeks to. And also in AI is think about automotive cars. Is if you are able to make these instant optimizations on routing and how to navigate through the road system, even though you could also apply like edge. So there's like so many overlapping scenarios, but you can take it to AI, you can take it to chemistry, you can take it to physics. It has applications almost everywhere.
Mm. Yeah, and isn't the traveling salesman, isn't that kind of like another classic example that they talk about quantum, or am I confusing that too?
Yeah, any optimization problem, it's like if you want to find the best path, the best route, using quantum computers, you can do it very easily as compared to classical computers, and faster.
Yeah.
That's so amazing. Interesting. Yeah. Let's come back to quantum. I don't want to, I want to make sure we get in all of our topics today. So take us back. You started working on the CRISP project, and this is sort of like the beginning of your open source journey, and it brought you into, so many other projects. So what is the CRISP project, and how did you get involved?
So in the final year of my grad university year, I was connected with a Mass Open Cloud, which is kind of like an open cloud in the Boston area, and it's made up collaboration with universities, Harvard, MIT, Amherst, my university, Northeastern, and BU, and I did this graduate research assistantship in MOC, and from there I was introduced to the CRISP project, and I've been intern on the CRISP project. So those of you who don't know, CRISP project is a collaboration between Red Hat, Boston University, and Boston Children's Hospital. And we are developing medical imaging software that could make clinical results more relevant. And by that, I mean to say that right now, if you have to analyze 10 to thousands of MRI, it takes a lot of time. And let's say that you had an infant who has a very rare brain disease, it would take you a lot of time to even find out because you don't have as many samples, or the doctor has not himself or themselves seen such scenarios. But if you reduce that time from days to minutes and hours, you can get, it is more relevant. You can start attacking the disease. You can find a medical path to take for the prognosis. So that's what I've been working on, the CRISP project, and that opened the door for my journey to open source. And then I was hired at Red Hat, and I continued to work on the CRISP project, which belongs to the research team at Red Hat, and I was there for like a year, and later after a year I moved to the emerging tech team.
So interesting, and it's interesting, for, because it's open source, but also that it has this tech for good, but like real world application as well. It's not some sort of like theoretical thing. It's like doing good immediately, open source, and a tech for good. I love it.
Yeah. Think that that's the power of open source. Sometimes you can see the impact happening like so close to you, and it does not need to take like 10 to 2 or 3 decades for it to actually make an impact. You can see that it's just happening right there, and you don't need to be like, for example, if somebody had to work on this, either they had to be an employee of Boston Children's Hospital or they had to be an employee of Red Hat. But a student like me got an opportunity just because it's open source and anybody can go and contribute into it. So that's the power of open source.
Yeah, and I think too, one of the other kind of smaller aspects of open source that we talk about sometimes here is like, it sounds like you got a job through open source, which I think is another great benefit of doing open source. People see the work that you're doing, they interact with you, they find you to be professional, easy to work with, but also doing great work, and jobs come out of that. I've seen that happen many times. It's great.
Yeah, that whatever work you do, it's out in the open. Anybody can go and analyze that. It's not like proprietary software that you don't see what you're making.
Yeah, exactly.
It's out in the open.
Yeah, in the open. Well played. So yeah, this is interesting. And is this something you still work on, or do you know what the status of the CRIS project is currently?
So my interaction or the time I spend has been reducing significantly. So I started with being an actual contributor, then I was managing that project, and now I'm just like try to connect the right people with the right team if they have any CRIS project related questions.
Very cool. Yeah, that's really fascinating. You've got the link up there. I encourage people to check this out because it's really quite interesting and a great practical application. And
I only briefly looked over it, but what I liked about it too was it seems like the way it's set up is also like a very modern or contemporary computing structure. It's using containers. It's using compute clusters. So it's like, yeah. I feel like there's a lot to, besides doing good, there's a lot to learn from just how it's executed.
Right. So we do use OpenShift in CRIS project as well. And again, the idea is to how you can scale this system to immense power so that you can do the computation really fast. And my contribution to this project was to introduce the scale, and the portion I developed was how you can run it on OpenShift, and you can do horizontal scaling from 1 pod to 10,000 pods as needed. So it has all the new technology. It uses containers. It uses OpenShift, which is the heart of all the cluster.
Mm-hmm. Very cool. Really cool.
You know what comes to mind too, Joe, hearing this is in our last episode, we had Ted Tanner and Adam Orentlicker on from Watson Health, and they were talking about one of the projects they were talking about was Linux for Health, and about how Edge is such a big component of that because of huge data sets, because of security, because of network considerations, and I could totally see how I hear about this project, I hear that it's using OpenShift, and then talking about some of the projects we're about to talk about, it's just weird how I can see all of these things. I could see microshift being on Linux for Health, right? It's weird how it's all, there's a lot of like connections to be made here.
Yeah, and James Snell before that one as well. Yeah, we've got a thread going here that I don't think we really even planned, but it's fascinating.
So let's. I wanted to ask you about the volsync. I think that's a good next sort of step in our journey of exploring this space. So give us like the high level overview, and tell us sort of what aspect of it you're working on.
Mm-hmm. So the volsync project started with how you can do. Sorry, one sec.
Take your
Oh,
time.
boy.
Yeah, how you can do data mobility on cluster. So it is very easy to move applications, and but if you have to move stateful applications that have data and that have states, it's very difficult. Right now, you can use not just difficult; it is also depends on the storage system you use, and it has to be that the primary site and the secondary site has to be the same storage. And right now, how people do it is they rely on the whatever the storage system they're using. They expect that it has a data mobility feature that can help you to move data. But you can just imagine how much reliance not just on the storage system for storing the data, but also managing it, backup, and disaster recovery is. So we came up with this operator, the volsync operator, and basically what it does is it provides a storage system independent mechanism for data mobility. And the use case you can think of is not just simple disaster recovery or backup. You can also do data replication. You can manage data in a multi-cluster environment using simple GitOps operation. So that was the motivation of bringing volsync, how to make data mobility in clusters very easy. And it has the specific case that I was working on was how you can replicate data in a one-to-many high fan-out scenario where you have a primary cluster from where you are distributing or replicating data to multiple edge devices. So that's a specific use case that I've been working on, and quite interesting. I gave a talk about it yesterday, so go and check it out. Search DEF CON volsync, and you will find that presentation. So the use case is how do you do it using the underlying Kubernetes CSI components to do data mobility and not actually relying on the storage system itself.
So interesting and so exciting that you presented at DEF CON. What a cool event to have on the resume.
Yeah, really cool. So I'm reminded of, and I want to ask if this would be applicable here. I saw a talk a while ago. This woman was working in Africa, and now my brain is kind of not working very well, so I can't remember what the disease was, the pandemic was there, but she was trying to do tracing. And a lot of people were in an area that they didn't have a lot of connectivity. And so they would do it locally. And then when they got, online somewhere, then things would kind of sync up. And I guess I kind of wonder, does volsync do that sort of stuff as well? Like offline and syncing and replicating, but also being able to deal with being, limited connectivity and such?
So for volsync, if you're using volsync, you would need to have at least a network connectivity when you are replicating. But it's so cool because it's schedule based. So let's say that you don't have access to network all the times, but there's during the time of the week or time of the day when you have access to network. So you can schedule your operations to run at that particular moment. You can set this schedule in the operator itself, and whenever the schedule is on, the operator would be replicating the data. So how it happens is you have a primary cluster, and we imagine that the primary cluster could have internet connectivity all the time, if not, again, on a schedule. And the primary cluster puts all the data onto an intermediate storage unit that could be an S3 bucket and an object store, and all the edge devices that you have, that also runs on a schedule. And whenever the schedule is on and it has internet connectivity, it will just download the data from the intermediate storage unit, and it will provision the underlying volume on those devices to get the data from the data that was replicated recently. So you don't need internet connection all the time, but since it is schedule based, and if you ensure that at the time the schedule is on, there is network connectivity, it will do the job. And actually, that was the idea behind is for the use case that we were working on is it is for edge devices. Imagine drones that are set out to get pictures, and they have like limited space also, so they cannot be like can store a lot of data on those drones. But if they're running on a schedule, they go and collect the data. They go to the far North Pole and South Pole, they collect the data, and whenever they are near the observatory or laboratory, they have internet connection, and they would just the copy or replicate the data or download the data or upload the data. So that this example, I guess maybe it was Ebola, because that is what. Yeah. So it is for use cases like this, like far edge devices that have limited network, that have limited storage, and they can use volsync to replicate the data.
Yeah, that's fascinating. I think, I know tech can't solve all of the world's problems, and we'd be a fool to try to do that. But I think it's really interesting to try and think of ways that we can, apply technology to be helpful and solve some of these problems or parts of the problems, and tech for good.
I just thought of something really quick. I think we may be taking for granted that we understand what operators are and how they plug into OpenShift. I feel like maybe we should just take a little definition. So for our listeners who are like, what is this operator? It sounds like magic. Well, maybe Parul, you could just give us that high level overview.
Sure. So think in the old time when you had to manage an application, you are responsible to seeing, is it updated? Is there a security patch that needs to be applied? If it's down, you have to restart it. So in a very simple term, operator takes all these tasks from a human, and it is like a binary that would be managing your application. So not just running the application, but also updating the application, applying any security patches that has been, or any vulnerabilities that's there in the software. So, and operators are, when I'm talking about operators, I'm specifically talking about Kubernetes and OpenShift in mind, like when you're developing operators for Kubernetes. So the volsync operator is an operator, Kubernetes operator.
Excellent. Yeah, I sometimes it's so easy to forget that there's things we need to unpack and explore a little bit.
Yeah, I thought that a few times too. We should take a moment and explain what operators are.
I was also going to mention, the use case for this, that came to mind. I recently got involved with some agriculture projects, and there's this, I think he's actually listening. My colleague, Joe Pearson, is part of the Open Horizon open source project, which they use in factories and all sorts of things. But that software is now being applied for agriculture. And this exact kind of use case comes up exactly like you're saying. A field or a ranch, it's a huge space. You're not going to have connectivity, but back at that barn or that ranch house, there will be, right? So maybe the tractors or the drones or whatever's traveling and traversing that property, when it goes back, it can update that data, update its models, and then go offline, do what it needs to do, collecting new data, applying those models. And then when it comes back to that point of connectivity, and I think we have some other, when we start talking about the microshift, I think we have some other really neat edge cases that we're going to bring up around the CubeSat, which is like, to me, the ultimate, I know we're really excited about this topic, Joe, but the ultimate edge case is, outer space, right?
Yeah. So I would say that microshift is a bare minimal Kubernetes cluster. It's kind of like a flavor of Kubernetes, and you can think of volsync is an operator that would be running. So just for people who don't have very much tech background, the difference is volsync would be an application that would be running on microshift, if at all, and microshift is a bare minimal flavor of Kubernetes. You strip off all the things that you don't need, and you just have made it. It can work in adverse network connection. It can work in adverse storage and CPU and memory. So it's a very minimal flavor of Kubernetes that is designed for far edge devices. And I saw the tweet from Naeem yesterday, and he mentioned microshift. So that was like pretty cool. That just made my day, and was so fortunate that I'm working on microshift.
And if folks are interested, Naeem is the space CTO at IBM. And we've had him on the show before. He's involved in lots of cool projects, and one of them is a CubeSat. And what it has a name. Is it Endeavor? Is that what it's called?
I think so. It's Endeavor. Let me just.
Yeah, but very very interesting project. We'll put it in the show notes as well. But it's interesting to hear that, microshift is going to be running on the CubeSat in outer space. We should get into microshift, but maybe we're about halfway through our time. Maybe we should do a little break here, let folks know about what's going on with IBM Developer and podcasts. And then when we come back from that break, we're going to talk about microshift.
Sounds good.
So thank you for tuning in. Again, if you have any questions, please drop them in the chat. We'll get to some of them towards the end of the show. We'll also, our Twitter is out there. Feel free to tweet at us. We're happy to engage. You can always find our latest show at the top of ibm.biz/in-the-open, as well as all the archived shows below. There's also a link on that page to our podcast page where you can find the audio version and links to your platforms of choice. So and there's also a direct link to those podcasts. So if you don't feel like watching the stream or the replay of the stream and you want to catch it as a podcast, I also clean up all the ums, ahs, and buts on there. So it's a more concise, tidier version. I sound much more eloquent.
It's mostly me.
Joe is always eloquent. Our guests are always eloquent. It's me. I'm cleaning it up. And I would also mention, developer.ibm.com. The parent page for all of these podcasts. There's all kinds of great content on there around, blogs, videos, all kinds of enterprise and open source tech on there. I would recommend checking out. So, let's shift back to our topic at hand. Let's talk about microshift. And so it's related. I see how it's related, and the space you're in, right? You're kind of in this emerging tech edge space, and these are related projects. Give us the rundown about the high level of what's it used for all over the place, and then what part are you working on?
So first thing, when I work in emerging tech, it's very important to know that we don't work on any products. We are working on pre-productizing team. So everything that we are doing is in a pre-productizing stage. It's not actually released for commercial. So microshift is an experimental flavor of OpenShift and Kubernetes, and it is optimized for edge devices. And by that, I mean, the target use cases are your standalone edge systems that uses Linux to edge clusters that runs on OpenShift and Kubernetes. So microshift is targeting the bare minimum things that you can that you can have in a Kubernetes cluster to run your workflows, and it relies on the underlying operating system security configuration, rollback and updates mechanism. And microshift itself, it runs just as a deployment on the operating system. So what you can do is you can just image a device, and you can take that image and go on-site and plug it to a network, and boom, your applications and your workloads would be on those devices. So it's just like a very simple plug and play that needs bare minimum networking connections. It can also work on disconnected devices, because if you're able to carry an image and just plug it into the edge site, it can be run as a disconnected service as well, as long as you ensure that all the images that you have, all the container images that you have are available on those systems, so that it can just pull those images from the image registry. And so that's the nutshell about microshift. What I am working on is it's a very young project, so we work on everything. Is like we have whoever gets to tackle what they're doing. I'm the part of work that I'm doing is just how you can. We are just refactoring the code to have like an internal service manager to start all the Kubernetes and OpenShift services. So nothing specific. Everybody's working on everything on microshift.
That's really cool. I wonder if we should step back just a moment, and we talk about edge computing, but and I think we've touched on a little bit here, but like, what are some good examples of edge computing, and why, for our listeners, do you need to adapt for those environments, or those computers, those edge computers?
You mean to say the kind of use cases? Yeah,
and I mean, they're typically smaller computers, Raspberry Pis, things like that. So you have to kind of build these things to run on these different devices, right?
Right. So we also have, like for the CubeSat, we are creating the multi-arc image of microshift so that it could run not just on x86, but it can also run on ARM or like any the underlying device that is compatible with the whole CubeSat ecosystem technology. So it runs on multiple architecture. It's not just really made for x86. It works on Linux. It works on Windows. It works on Mac OS. So it is optimized for all the different OS as well.
Very cool. Very
Yeah,
cool.
and it's the I think like you have to think about how what are the minimal things that you can have on edge system, because an edge device is not a full-fledged cluster that you can have like a server. So just think wherever you cannot afford to have an entire server system running, you can run microshift on the bare minimum resources that you can have.
Interesting. You got a link there, Luke? I saw you pull something up.
Yeah, I was going to say I totally got the name wrong. It's Endurance is the name of the CubeSat.
Oh, cool.
I'm going to edit that out in the podcast, and I'm glad I didn't get any messages from Naeem during the show like, you got it wrong. But yeah, this is the CubeSat project, and there's something where you can, I think it's still open, where you can submit and get your name on the CubeSat, which is like and it uses a quantum computer to like generate the UUID or something. It's very interesting.
I am trying to find that tweet. I'm just like not able to at this moment, but I will share it with you once I have it.
I think to answer your question too, Joe, something that you were getting at there, it's like the unique edge cases of the functionality of edge, right? And I think, an example too would be like self-driving cars, right? Like, you're not always going to have connectivity, but it's going to have to be able to do those things. And this is why it's such a hard problem. No one's, been able to really pull it off 100%. But I feel like that's that thing where it's like, sure, if I'm playing a video game and I go offline, okay, I can't play, offline, but I'm still playing, that's not like the same kind of scenario. It's these scenarios where like it's mission critical. It has to still be able to run offline. And it almost reminds me of like, there's this, one of my favorite films is Errol Morris, Fast, Cheap, and Out of Control. And it references, I think it was actually MIT scientist who wrote the paper about creating swarm bots, right? And this idea of, and it's like ants, right? Like distributed intelligence, right? They're all kind of doing their own thing. But together you get this emergent behavior of how all the things work together. And ideally with these edge scenarios, you want that system to still function if it can't make that call back to the main cluster.
Right. That car is a great example. Even if you had seen, I think Naeem was in your in the open conversation earlier, and he was also talking about when you are running these experiments in the space, and it's at that time when again you have like very limited resources over there. So it's anything that is disconnected network, limited resources, limited memory, limited CPU. We call it like a far edge devices, and microshift is suited for those kind of deployments.
And are we thinking too, like, I mean, these are, like you said, mission critical kind of things and whatnot, but also like, my toaster oven and all sorts of like everyday items, right? I mean, these are considered edge devices as well, and will become smarter and more capable to do all sorts of things that, maybe we don't want them to do. I don't know.
Well, it's funny you bring that up, Joe, because they don't seem like they're mission critical. But something else I know we wanted to talk about today was, sustainability. And I think there is a big connection here, right? Like I know some air conditioners already have network connections. So like the power company could turn them off in case of a power crisis, because that's what could tip the scale. So, it seems trivial, but something like our refrigerators and our toaster ovens and these things at scale altogether, actually, I think there is a use case there for being able to, collect data from them and, potentially being able to, communicate during times of crisis.
Yeah, no, that makes a lot of sense. Fascinating. That's perhaps another good segue, talking about like sustainability and the environment. I know that's something that you're very interested in, Parul. You want to share a little bit about that?
Uh, I I personally I like to live as sustainable and as green as possible. I have not consumed single-use plastic for a year, and that's something I'm very proud of. So one of my hobbies is I picked up woodworking, and what I do is in my current house, except for my couch, all the furniture has been built by myself, and I don't use any new material for that. People leave a lot of stuff on the curbside, so whenever I find something that can be viable and that can be upcycled, I just get that. I strip it off, the paint, the coating, and the stain, everything. It's a grueling process. It's very tough to live a sustainable life. It's not easy, but I made that oath that I would not be buying anything new. As much as I can avoid, I don't buy anything new. I try to refurbish or reuse or upcycle anything that's available. So that's the sustainability life I'm trying to live.
That's amazing. You've been doing that for a year, you said?
Yeah. In the pandemic, I picked that up because I had nothing else to do. You couldn't go out, so in the basement, I've been collecting these scrap pieces of wood for a long time, having in mind that's something I'm going to do out of it. So in the pandemic, I just got all my collected junk and then made something out of it.
That is so interesting. I knew we wanted to talk about sustainability, but I had no idea that this was the rabbit hole we were going to encounter. And one of our listeners, M. Greigels,
I think that's probably awesome. Mary. Is that Mary?
Is that it? Might be.
Yeah.
Oh yeah.
Yeah.
That is Mary. Hi, Mary. But that is so interesting. And just to sort of reflect here, it's so interesting. A lot of the folks you meet within the tech and development industry, you respect what they're working on at work. Very interesting. And then you scratch the surface and you find that like, oh, wow, there's so many other interesting hobbies and avocations around folks in development. So happy to hear you share that. And I'm similar. I have like all kinds of tools and I'm renovating a house and building all kinds. I moved into a house that was like a shell and have been building it around myself for the last year. It's been harrowing.
Yeah, it's really cool to try to salvage old stuffs and not to pollute more, because it's if you think everything that you buy is eventually going to end in landfill, and it is such a daunting thought. Like one day I was just sitting like, oh no, I cannot do this. And you wouldn't believe, like when I was in my really early 20s, I used to buy a lot of clothes. I was following fast fashion, but then there was a time when I realized everything that I buy is going landfill, and they're gonna live on Earth for more number of years than I'm going to, and that was so terrifying.
Yeah, it's so true. And I think, even if you aren't like fully on board with the sustainable, not buying anything new, I think there's still a lot of value in just finding interesting things and refreshing them. And, like we found an old dresser that we thought was really interesting, and you strip it down and put a cool color on it and some hardware. And now you got this really interesting, piece of furniture. And I'm curious, I'm trying to imagine, do you have a garage out there and a big kind of woodworking setup? And
No, I am like an edge device. I work in adverse conditions. I live in a condo, and it's a building.
No.
So I go in my basement and I chop wood, and chopping is not that sanding, because when you want to strip on a color, it is really loud. So that is like, I'm just waiting to get a notice. Oh, you are a very loud neighbor, tenant, get out of the building.
Yeah, that's funny. We were losing you a little bit there, but that's comical, because you're in an edge device kind of world. We might not have perfect connectivity, so that's fitting. But yeah, that's funny. I have an apartment here too, so whenever I'm doing some work, when I'm at the apartment, I'm always like, oh, the neighbors are going to hear me.
Are they complaining about your guitars, Joe? Is that happening yet?
No, because I have some amps here, but I don't plug them in. I just plug them into the computer and put my headphones on. But I keep daydreaming about setting up a drum kit, but I don't think my neighbors are going to like that. We'll see.
So this question, it's not directly related, but it's such a perfect question for a Red Hatter. I thought we would bring this in real quick here. Shaw asks, how can a company earn money from open source software? Red Hat's the best company in the world to ask this question about.
Okay, so I will tell you what I was told in my orientation program. It's like how you earn money from open source software. Think of open source software as water running in a stream, like in a mountain stream. That is free, right? Like it has all the minerals, all the salts that you want, and it's spring water, so crave after. So if you want to drink spring water, what are you going to do? You can hike up the mountain, you can bring your tumbler, you can go to the mountain stream and you can drink it. Or you can get a company that packages that water for you, put it into a bottle and give it to you. So open source does not mean free. Open source means that it is available for everyone to see. Everybody can have the code. And if you're willing to put that much energy into managing it, ensuring that all the security, it is secure, it has always updated, then you can use it for free. You can just clone the GitHub and you can just start building your own executable. But if you don't have that much money, that much time and resources, then you just take it from someone who will do that for you. So that's how open source company makes money.
That's a great analogy. I'm not sure what the term is, but that's a great metaphor. I'm going to use that. And I remember seeing when I lived up around Saratoga Springs, there were a few spots where people could go and fill up their plastic jugs. They didn't have to hike up the mountain. But even still, and I remember we did that a few times, but most of the time we just got our own water. And so that's an example I can really relate to.
That is a great example. And I like, too, how it illustrates when and where you would want to pay for it. If you live on the mountain, okay, great, just get the water right there. But how many of us live on the mountain next to the spring? And, do you have stuff to do? I'm trying to make breakfast. I need that water. I can't hike 10 miles to the mountain and back just to do that. So it's interesting to find that breaking point of like, oh, this is why I want to, use a product based on a project, because it actually does provide that value for where I'm at and what my resources. And like you said, time is the biggest resource, right? Like how quickly can I get to value for, my customers and my industry?
Yeah. So and still it's open source. So it's like if there is any, most of the company, like for example, if you are at Red Hat, we have lots of upstream projects, and from that we make a downstream. So all those innovations and creativity, it still goes in the upstream project. And if you're buying RHEL from us, you are ensuring those innovation and creativity are still there, but you're also ensuring that it is secure, it is reliable. There would be somebody to help you if something goes down. So that's again is like one of the why company follow or would like to have an open source ecosystem.
Mm-hmm. And RHEL being Red Hat Enterprise Linux. Sorry.
No,
it's okay. So very interesting. I'm curious if we kind of shift gears a little bit here. You working in emerging technologies, what are you excited about? Is there upcoming work that you're expecting to do, or what's kind of got you excited about the work that you're doing?
The things that really excites me is the innovation, is because we are thinking a year in advance, and it's like the actual team or the products, it's not realized, it's not released. So we are kind of like, I like to say that we are the trendsetter. We go and see what is going to happen, what the market is going to evolve in, and we kind of do a lot of prototyping and analyzing the whole sector, and then coming up with solution, and then working on those solution. And trust me, not all of them goes to product. most of them are scrapped out, but the thrill that you get in this thinking in advance and kind of visualizing where this whole thing is going to be it's like really exciting and thrilling.
I think just to reflect on that, it seems like it's a perfect time period too, right? It's like enough that you can actually see the results. Whereas like if you're in some sort of pure academic or, research, which is awesome, like science, but it may, it may be like you're saying decades or something till you actually get to the product. Whereas like this space you're in, it's closer to what maybe traditional applied research was, where it's like there's a short enough horizon where you could actually see the results and get things done in a year or two.
Right. Yeah. That's super exciting. And for me, I would say it's like the variety of projects that I get to work on. It's just imagine like in a year, I move from quantum to edge computing, and that is super interesting. It's like not many people get to do that. They take up a role and they continue to do that. It's not like it's not valuable or it's not acknowledged. That is, but I think like I really enjoy the pace of work. It's very fast. You have to learn things very quickly. You have to be very adaptable, and then you have to generate code in a very short time. So that is very exciting for me.
I can imagine someone listening to this and thinking how awesome your job is. And so I would imagine people wondering if you're hiring, if you're doing this hiring. And maybe you don't know, but I thought I would kind of just pose that.
They can always come back to our Red Hat jobs and find if we are hiring, but my team is like super interesting. So if anybody is interested, go and look for jobs in emerging tech group of Red Hat and do apply.
Yeah. I looked it up. redhat.com/jobs, I think, works.
Yeah.
And then, IBM does a lot of research work as well. So like careers.ibm.com, you can check out there as well. But I can imagine people listening to this and being like, I want to do what she's doing, So that's exciting. That's great.
I would comment here that is actually one of my biggest surprises of working in the enterprise is how interesting it is because of that diversity of things you can get involved with. And, I think this podcast is my version of that, where it's like, oh, wow, this week I can talk to you, Parul, and hear about this. Last week I was hearing about health. Hopefully we'll have Naeem on later this quarter to hear more about the satellite. So that is one of the things I think that a lot of people don't realize, that the enterprise is very exciting because everything's at scale. It's big, it's real right away. And there's such a diversity of topics and industries.
Yeah, for sure. Mary asks a question here that we'll put up on screen as well. Do you get to choose the topics that you like to work on and the tech stacks as well?
So the topics is usually how it works. Like the team decides what are the new things that they're gonna take up, and then the people on the team decides what they are interested on, and they work on that. But I would say there's little flexibility, but it has to be aligned with Red Hat strategy. Of course, like as long as it makes sense. And as I said in the start, my job is to go and see the emerging technology trends and then find out how it can be aligned to the Red Hat strategy overall. So I wouldn't say there has to be a discard, but as long as it ties down to what Red Hat strategy is, you do get to choose the topic and the tech stack that you're working on.
Yeah, that's cool.
Well, and it sounds like you already were predisposed to sort of the same ethos of what's going on at Red Hat, having a passion for open source and collaborative working. So it seems like it's a great fit that way.
Yeah. I love open source a lot. It's because you get to work with so many diverse and smart people. And I believe in the philosophy that you are 25% of what people you're surrounded with. So, and open source is the best way to surround yourself with really smart people. You all do not need to work in the same company. You can be anywhere. I collaborate with people from IBM. Like when I was working on the Qiskit operator, I get a chance to collaborate with the Qiskit team that is in Spain. That I couldn't have conceived that I can do that in a normal job. So that's super cool.
Yeah, very cool.
we have a bit of a technical question here about edge and how communication. So how can the data be transferred between services? What type of data bus do you implement with events and queues around edge computing?
Okay.
That's specific to volsync, maybe, when we were talking about that, I'm guessing.
Well, I would interpret this. They didn't say edge, but I would say, what comes to my mind, and obviously I want to hear your answer over mine, is like MQTT and, sometimes Wi-Fi. Maybe if it's really an outpost, maybe it's using LoRa. I don't know. So I think it could be protocols as well as technologies.
I think it depends. For example, when I was doing for volsync, when I'm working specifically on for the edge use case, we are using HTTPS to connect to the intermediate system, but there one of the scenario uses rsync, and rsync works on the local SSH server. So it really depends on the use case that you have. But there's nothing specific. We do use queues sometimes when one of the operators that I'm I would just say collaborating or consulting the IBM, they use queues. So it depends on the use cases. I wouldn't say there's one strategy that say this fits all. It depends on the use cases, from anything from HTTPS to gRPC to SSH. It can be anything.
All options on the table with edge.
Yeah. We have another question here I wondered about bringing up. Can an individual earn money from open source? And that's a good question. Not an easy one, perhaps, to answer.
So if you say if they mean an individual who is not working for a company that do open source, I guess that's what they're asking. If yes, then I would say I'm not the right person to comment on that, because I was fortunate enough to find a company that does open source and pays as well. But I recently read this article. So GitHub has a README project going on where it's shared stories about people who work on open source. And these people are like individuals. They do not belong to an organization. So there are scenarios where people do earn money from open source, but it is kind of like not a very structured sector. It's like it is little hard for you to be an individual and earn money from open source, because again, you can have like so many people who want to use the project, but they are not contributing back. So most of the time you are an individual who is leading the entire open source projects. But it's not like a hard no. It's not even a hard yes. It's in between.
Yeah, I think in my experience, and I think you were touching on this in the beginning, is like there are kind of a variety of ways that you can interpret this question. Like, for example, you earn a salary and work in open source, and similar to me as well. And I know a bunch of folks from obviously Red Hat and IBM as well who are paid by our company to work in open source. So that's one angle. But an individual on their own, that's a little bit harder, but certainly there are people out there that are doing it. I used to work with a gentleman by the name of Henry Zhu, who is like the lead person on Babel, a JavaScript transpiler. And he, left, we worked together at Adobe, and he left Adobe to work full time on open source and was, I think making do. I think he has some articles and does a podcast, so you can probably read more about that there. But I think it's certainly not easy. And I think the other angle too is, like we had talked about earlier, like you can be working in open source and potentially get a job through that work. If you have visible work and you're interacting with folks at a company, there's an opportunity there to get hired as well. So it's multifaceted question and answer, I suppose.
I think these were both great answers. Yeah, it seems like it needs to be part of a bigger strategy, whether it's, and there's probably room where you could be a consultant around certain things that are important to the industry. But yeah, I love these answers, that it should be part of a bigger strategy of this is going to distinguish me in such a space so I can either get a job or be a consultant or, XYZ. But it's not just in itself. It's not like driving, Uber or something. Can't just pick it up and.
Yeah, exactly. Yeah. Well, looks like we used up another hour, another great hour of talking through some interesting technology with our wonderful guest. Thank you again for joining us, Parul.
Thank you for having me. It was fun. So much fun.
Yeah, I'm glad you're able to make it. And I look forward to working with you more and perhaps having you on again and talking some more about some cool and interesting stuff that you're doing in the near future.
Thank you.
Yeah. Great.
All right. Thank you for tuning in. If you're catching this as a replay on podcast and you have any questions, please tweet at us. It's been a pleasure bringing you this episode, and see you next time.
Yep. Cheers.
Bye-bye.